Let's begin. So I'm here to talk about Bazel for Android development. Bit introduction about me. So I'm an Android engineer at Grab. So more recently, I've been focusing on developer experience, build system, and a couple of core app metrics like app performance, architecture, CI/CD, and stuff like that. So previously, I used to work with Freshworks and Rightmark. So it was a mix of both business and consumer-oriented applications. So why are we here today? So today we're here to talk about Bazel, and but this talk is specifically adapted for Android engineers and uh, work with Gradle day to day. So this talks draws a lot of comparison between Gradle and Bazel and tries to give you an tries to teach you the concept of how it is looks like when developing with Bazel. So we'll start with the build configuration, which is the primary thing that we interact with every day, which is like uh, the code that we write for the build system. Then what support in state of Android support in Bazel? It's like where the community is at, what are the tools and technologies that you can use, etc. Highlight of the talk, which is Bazel, a bit more about what Bazel does and how it is managed to be performant and scale well to quite a bit of high large code bases. So if you have been deciding to migrate to Bazel or even try Bazel in one of your projects, so what can you do? What are the strategies that you can take? And what are a couple of open source tools that you have today that might help you migrate your Bazel? Finally, advanced Bazel, like there are a couple of Bazel features specifically targeted at big teams. This might or might not align with your expectations, but we still cover them on a high level anyway. So then finally, we conclude with the summary. So let's what is Bazel? So it is an open source build system from Google, the like current developer of Android as well. So it is based on Blaze. So Blaze is an internal system that Google uses to build their infamous monorepo, which has like lots and lots of thousands of modules, and Blaze is able to handle that. So it is multi-language and it has multi-platform support as well. That means that seamlessly you can have uh, let's say Python binary or a Java binary or a C++ binary in a single project, and Bazel provides you a sufficient abstraction to interact with all of them. So for example, I can write a simple action that starts a work with a Python library, then carries on over to a Java binary and stuff like that. So it is specifically designed from the ground up to be highly parallelized and supports distributed builds. So distributed builds are something that's not only run on your machine, but it can be distributed to a cluster of servers, for example. Now, it is known to be performant on large code bases. And this is a quite a bit of a statement to me. And I want to delve deep on why that is. So let's start with build configuration. Now we have a very simple build.gradle file here, right? So this is something that we as an Android developer will be quite familiar with. So in a build.gradle file, we typically have plugins, couple of extensions, couple of statements that we can call to configure the build. This looks so innocent at first, but I would like to focus on one statement here, which is println, and it is printing the current system 10 milliseconds. So as an engineer, I run this build. I expect this time to be printed. That's all. But let's imagine from at scale that you have thousands and thousands of build.gradle files, and the build system is trying to be smart, right? So the best work that a build system can do is no work at all. So if build system is able to skip doing a lot of work, then it is win for you as a developer. But as soon as I introduce this println statement, let's assume I'm on a build system. It puts me in a difficult position because I have to give the correct output all the time, but at the same time, I have to evaluate this build.gradle all the time, even if you don't change it. So you can write it, but I still have to evaluate each and every time that this code runs. So this quickly becomes a problem. This is a symptom of a problem that we have with Gradle, meaning the right there, not exactly cacheable, or it is available to the build system to say, okay, this file is up to date. I cannot simply look at the build.gradle file and determine it is up to date. What if there is a if-else statement and the if needs to be evaluated? So this has to go through a runtime. Now let's see what build configuration on Bazel looks like, and we'll get back to how it works on Gradle. So Bazel uses a dedicated build configuration language called Starlark. So they went ahead and built a dedicated language just for build configuration. This seems like a lot of effort when we have like well-defined good languages in our like to be have in the programming community, right? So why does it so? I personally am fond of Kotlin a lot, and I like that I can configure my build with type safety and stuff like that. But I still have learned to like Starlark a lot. Why? Because it is a very small and simple language, and it carries Python dialect, and it is tooling friendly. By tooling friendly, it means that build systems like it can any other tools can process the build system, the build configuration, make some changes to it, and then write it back. So this is very useful when you want to build a lot of automation tools and build validations or stuff like that. This is difficult on the Gradle side because just by looking at the build.gradle file, it is very difficult to determine what plugins are applied, whether the plugin itself is causing a configuration or something like that. So, and it is again designed from the ground up to be parallelly evaluatable and also favors immutability. That means a single build Bazel file, when you're sharing with another Bazel file, by default, the constants and everything are frozen. So this is done at the configuration level to make sure the builds can be parallel. So it also does something called hermetic execution. So no access to file system, network or system clock, which is interesting because as a build, no access to it has access to the file system, just that during the configuration phase, you don't access. So, uh, yeah. So back to Gradle, the configuration phase is single threaded at the moment. So when you have thousands and thousands of build.gradle files, all of those files are going to be evaluated serially. Now, secondly, it is difficult to track whether build.gradle dependencies are changed or and whether we can evaluate cache from it. And at the same time, this is a known problem with Gradle, and there are certain initiatives from the Gradle team, such as configuration cache, which helps to reduce the incremental build time. Basically, it serializes the entire build graph, writes it to disk, so that next time you perform the build, instead of reading the build.gradle again, it tries to fetch from the configuration cache. But Bazel goes one step ahead in that as well. So first, all the build files are evaluated in parallel. That means when you have 1,000 files, Bazel tries to map the dependencies between them, evaluates them in parallel, and it also does incremental evaluation. So you have 1,000 modules, you make a change in one single module, we update a dependency. So the next time Bazel runs, it is only going to run that specific module for evaluate that specific module for compilation. Now it carries build.bazel and Bazel extension, which we'll discuss more in detail. This is how a load statement looks in a Bazel file. Here, it is very easy to parse out by any tool that I am depending on a utils.bazel file and I'm importing this simple like merge R classes. Now, settings start Gradle and Workspace. So I've tried to draw a comparison between the tools, the APIs that we use in Gradle and the closest similarity that we have in Bazel. So in settings of Gradle, it is very easy. We declare a couple of plugins that we use in the project, add a lot of libraries, which we call modules, and then that's all. Gradle configures these modules for compilation and does. So similarly, although not exactly the same, we have Workspace and um, Bazel, which can be used to define project-specific dependencies that are not necessarily local. So that means that this is quite flexible in how you fetch your external dependencies, right? So you can have a Git repository and simply add a Git repository rule here, and then specifically fetch a specific commit and start compiling them. I mentioned a word called rule here. We'll circle back to it. And uh, Gradle prefers plugins and Bazel has rules. So what a rule means, we'll discuss in the upcoming slides. So what about external dependencies, right? So typically this is how where external dependencies are written in Gradle. So we have an implementation configuration, that is, this configuration is from the Java plugin and a couple of repositories defined. And Gradle can download this daggers AAR file, pom.xml or jar file, depending on the library type, and then set up for compilation. Similarly, we have Maven install, which is again a workspace tool. So when you have workspace, it typically means that you are setting up your build with a lot of things that it needs. It can be SDKs, it can be other form of rules that helps you download certain things. A good example where it helps you download all these Dagger jars and configure it as a build target for your build. Now, root configuration, let's go to specific modules application configuration, which is built on Gradle. So this is quite easy to understand. We have the Android application plugin, couple of configurations, and then we have the dependencies declared based on the project function. The similar thing in Bazel is a rule call. So we are actually invoking the Android binary. One thing that I want to stress here is that it very similarly looks like a function call because it is actually a function call, and this creates something called a rule. In Bazel, we don't have a concept of plugins or anything. We just have rules. And if you want to build complex out of it, you combine several rules and merge them into one. A simple example might be the Kotlin Android support. So Kotlin Android support needs Android's pipeline for resource processing, and it needs Kotlin's own compilation for own flow for compiling Kotlin files. So both of them are merged and created a new rule. So it is like a bit like a composable function where you keep on more composition to the thing to add more rules. And second of all, this is non-imperative code. All the inputs are frozen. You cannot write an if-else statement here. You cannot write for loops or any other complicated code that you can configure dynamically. I shouldn't say that dynamism is not completely allowed. It is allowed in certain cases, but that is beyond the scope of this talk. So because it is so strict, Bazel can parse this file, determine the inputs have not changed, and completely skip evaluating when you don't make any changes. For example, if I make a change to version code, only this file is going to be evaluated. So what about project layout? So this is how a typical build or Gradle looks like. Gradle build system stuff looks like, right? So we have settings.gradle. We have build.gradle for each module that we have. Here you have Android, Kotlin, and possibly an Android application tab. Now, how would it look like when you migrate to Bazel, or what is the recommended approach? So we have build.bazel and similarly, and a sibling to settings.gradle, we have a workspace file. So workspace file is responsible for setting up your Android SDK, downloading your Maven repositories, possibly relying on a couple of other things. Let's say you want to add a rule for detect or code style or lint check. It probably belongs in the settings workspace repository, and those targets are then again used in the build.bazel file. Now, while this works, Bazel goes further and asks you to parallelize or break down your project further. So what this means is that in addition to having a build.bazel in the sample Android root folder, it is recommended to have build.bazel on each package that we have in the project. Why? So we have two packages here, package one and package two. So what if they're independent, right? So it can be a service, it can be an activity. They don't have any means to interact. Bazel can actually build those code in parallel compared to when you have a single build.bazel file. All of the Kotlin classes or Java classes is going to be combined into one. But when you break this build target into multiple build.bazel files, you are effectively creating more nodes in your dependency graph. When you have more nodes in the dependency graph, Bazel is very smart in parallelizing them if they are independent. So that is why it is recommended that you have a lot of build.bazel file. One easy thing to grasp is to simply look at the Bazel source code on GitHub. It is a monolith. It looks like a monolith project. It has a single SRC folder, but if you export the SRC folder, it has a lot of build.bazel file, just like this, meaning the entire build graph is broken down. It is not like a single SRC folder and that the entire compilation is serialized, but in fact, it is parallel. Now, as I said here, breaking down helps parallelize the build, and this is a recommended approach. But at the same time, this is not a all size fit solution. When you're adding more build.bazel files, you're effectively increasing the code your your build system touches, right? So the code you write for your build system. So the trade-off here is to write them, and there are, on the other hand, while it is verbose, it can be also manipulated with a lot of tools. So and there are automated code generators exist, which helps to manage this build.bazel verbosity in a Bazel project. So a couple of miscellaneous things before we delve into other topics. So we have Gradle wrapper, which helps you to manage different Gradle versions in your project, right? So this is something that most Android developers would be familiar with. So the Bazel equivalent of that is called Bazelist, and that is the recommended way of invoking Bazel. So Bazelist takes an file called Bazel version, and you can specify different Bazel versions, and then it automatically, transparently downloads the Bazel binary from GitHub or various release vendors, and then allows you to compile with them. It can also even use a Bazel binary that is on your system by specifying a special path in the tools folder. Now, we know that any build system is not without flags, right? So we might have interacted with a couple of flags in Android build as well. For example, in Gradle.properties, it is common to write a couple of flags for JVM arcs, non-transitive arc class, some capped flags and stuff like that. So the similar thing Bazel RC file where you can specify a lot of build flags and inject environment variables into the build. Now, finally, we talked about breaking down the targets, how build.bazel works, and how it compares with settings.gradle and Gradle APIs. So, as I already said, a single build.bazel file, it is simply a function call, right? So we saw that Android binary is a simple function call. Similarly, one build.bazel file can have uh, any number of function call. So each rule is the scope of each rule is within itself. It does not impact the neighbors or any other rules in the same build file. Contrast that with Gradle, you have a plugin, and the plugin typically applies to the entire module. So it is very difficult to have two targets managed by a single build.gradle file. But in Bazel, you can do that. So, and it is very common to build in Gradle, like say, okay, Gradle app assemble debug, which helps you to build the uh, debug version of the APK, and then you can maybe install it with install debug. Bazel does not have this task concept at all. It internally has it. It internally has a concept called action, but that is not exactly a one-on-one mapping between Gradle tasks because you as an engineer would not interact with it. But then how do I build it? So Bazel works by concepts called files. So the targets are referenced by that label. So if I want to build a package under sample and I want to build the APK, I just request the file output from the Bazel instead of saying, okay, the specific task name. I don't need to remember the task name or the action name. I just need to request Bazel, okay, build me this APK file, and Bazel automatically figures out what it needs to do and builds the files. Now we saw a bit about introduction about how can I actually interact with Bazel with Workspace rules and build.bazel and Starlark. But let's see how the Android support in Bazel is today. So right now we have Gradle, Android Gradle plugin, and Kotlin Gradle plugin. So most of the time they work wonderfully together, but there are also some places where one of them might be incompatible with others. But in essential, these are three different projects that has their own release cycles with a compatibility matrix attached. Contrast that with Bazel's current state today. So Bazel's Android, C++, and Java rules are coupled inside the Bazel binary. So when Bazel was developed, so there initially Android rules was written in Java, which is the language Bazel itself is built in, and then uh, it was packaged it. So while this works fine, what happens if I need to fix a bug in Android compiler? That means that I have to rebuild the entire Bazel binary all the time. I cannot use a separate revision for Android. There has been some work in the past to remove this coupling, but it is still there is a quite a bit of coupling still. So for rules Kotlin, it is a separate project. So we call them rules underscore Kotlin, and it is managed by both Googlers and community members as well. So going forward, the plan is to migrate from rules Android, create a new project called rules Android, where the plan is to migrate internal implementation to Starlark based implementation. So there are some open source components already available in the pre-alpha branch, but it is not recommended for production use. So as of today, the best way to start using Bazel is to still use the native rules, and as and when the rules Android matures, when Google open sources their internal Starlark rules, we could probably migrate to rules Android. So I want to talk a bit more about Kotlin compatibility. At the moment, data binding support is lacking. So a couple of newer features in data in Android Gradle plugin and Kotlin takes a bit to reach Bazel because of community contribution and a couple of friction involved there. So at the moment, data binding support is lacking, and we have managed to provide partial support for it via Grab's own specific rules that we have open sourced, which we'll discuss a bit shortly. So another thing is that since the Android rules are written in Java and not exactly Starlar, there is an interop story between how Kotlin rules can interface with the native Android rules with relates to resource processing. So once these rules are finalized, this step could be optimized. At the moment, it is a bit not optimized. And a couple of other things, of class path operations present in Bazel Java MPL, although there are work in progress and is being worked on different community members. Let's circle back to the performance here. So Bazel is artifact based, meaning it transforms one artifact to another. So, and you can visualize it as simply a function call. Let's consider pure Kotlin function that takes a list of artifacts and produces a list of artifacts again. This can be inputs, but Bazel goes one step further and says that not only the files that you need for building, you need to specify everything that you use in your build. That means if I'm using a Java SDK, that has to come as well. If I'm using an Android SDK, that has to be an input. This has historically been optional in Gradle, but all of the first party tools take care to provide sufficient input-output declaration for Gradle as well. Now, since you have sufficient clarity into inputs and tools, what can Bazel do with it? So the execution is highly optimized because it can guarantee that all the tools are required for the action are available to itself. It can execute the action in a variety of environments. One environment is called sandboxing, where a limited set of files are present for each uh, build. Only the files that are needed for the current action are available, where rest of the files are hidden artificially with the build. Another thing is persistent worker, which is similar to Gradle daemon that we have. And you can also take this action, run it on a cluster of servers remotely to potentially speed up the builds. And because of this, all the inputs and outputs need to be known ahead of time. That means zipping outputs is a common approach. So I cannot simply generate a file and with a random name. I need to know the file name in advance. This is a challenge, right? So what if a Dagger component is generated for Dagger component.java, but Dagger app component.java, but I don't know the app component in advance. So I also can't read the file. So this has been a challenge, and zipping outputs is a common approach. And one of the interesting things is that Bazel does not support per file incremental build. What it means is that in Gradle, when you make a change to a Kotlin or Java, Gradle is able to trace the file dependencies and only compile those dependents and also run annotation process around the changed models. But that is not the case with Bazel. where Bazel always builds everything. But this can be both make or break for your project, because if it is a large project and which have very big targets, all of the files is going to compile at once. And the better way to do that is to break your big modules either by creating separate Gradle modules or by simply using multi-target approach that Gradle recommends, that Bazel recommends. So it supports ABI-based compile avoidance, which is something that is lacking in Gradle, and it is available since Kotlin 1.7 with the any include class path snapshot flag. But what it basically does is that we have a hello function here, and I have a println on hello world. If I make a change to hello world string, Bazel is able to skip the entire and only build that module alone. It does so by producing a jar called ABI jar, which only contains the public methods of the public method without any bodies. So when I change hello world, this ABI jar does not change because I'm not changing the function body. And because of this, it is able to skip. And in our own experience, it is great for incremental builds where you can do combined with highly cached configuration phase. Bazel excels in this bit. Now, I want to talk a bit more about migration. So we have incremental, one-shot, or hybrid. So if you are looking to migrate, if it is a small project, it makes sense to do everything in one shot. But if it is a big project, there are a couple of risks involved. And it is better to do migration incrementally. So Grab has its own tooling called Gradle, which is a Gradle plugin that can migrate a project from Gradle to Bazel. It is highly targeted with our own project needs, but since it is open source, it should be easy to add your project specific criteria there. So the migration simply looks like this, where you have all the Bazel files. Then I'm simply running migrate to Bazel, and I have the Gradle plugin already applied to the project. Gradle visits all the configuration, generates equivalent build.bazel files, and then I can successfully build the project with Bazel, and that's all. And what about cases where you can't build the project, right? So that is where Gradle allows you to migrate the project incrementally. So it has a concept called hybrid builds, where you can build a certain parts of the graph with Bazel and then build the remaining part of the graph with Gradle. This way, uh, you have a feedback loop into how your build is progressing, and also allows you to keep Gradle as a source of truth until the migration is done. And while this is going on, it is non-destructive to feature development, because feature development can confidently happen in Gradle, while Bazel build is completely automated via these tools. And Bazel is open source, and you can find the link here. Any feedback welcome. So a couple of learnings is that Bazel has a concept called macros. Macros are way for you to write functions with Starlark. And again, there are a lot of restrictions there. You cannot read a file. You cannot do complex things like writing a recursion or something like that. And with this limited customizability, it makes sense to provide your own versions of the native rules. For example, you can have an Android library rule that is wrapped into a that wraps the native Android library. With this, you can add a couple of more validations or build your project specific needs. We have done something similar, and is on Grab Bazel Common, which has the collection of Grab's Android rules for projects built with Bazel. It has supports for data binding, running unit test, stuff like that. And it is also open source at this below link. So we talked about this, like let's hear about advanced Bazel as well. So we have a couple of concepts. We have remote caching. That means you're able to share results across machines with Bazel. You can have your CA populate the cache results and then have your local developers pull in from the CA results, thereby avoiding a lot of work. You can execute your build in a powerful cluster of servers. Let's say you have a very large project and it takes a lot of time to build on your local Mac. You can distribute the build to powerful cluster of servers, and the servers do the job and then download the result. So one such example is Bazel Build Farm, which is a project from Uber, and it is open source for you to try and deploy it in your own projects. Then we have Bazel queries, which is one of my favorite features because it is an API for you to inspect the dependency graph that Bazel produces. That means I can quickly say, okay, which all modules depend on Dagger, or which all modules should I need to compile to build this project. So there are a couple of interesting data that you can gather, and this is often the case. There might be dependency conflict and you're wondering which project is actually using this dependency, and Bazel queries are great for finding these things. So I like to go to the summary now. So Bazel really excels in scaling the build configuration aggressively. So we saw that it is able to cache most of the things, and even when it is not cached, it does things in a parallel fashion. And advanced concepts like remote caching and remote execution, because it provides a way for you to throw more muscle at the problem and then basically reduce your build time, because you're able to parallelize or utilize powerful machines for your build. And at the same time, Bazel is also carrying an upfront investment cost. So there is a set of divergence in the way the rules are written. So it makes sense to have a unified front for your own Bazel rules and how you're approaching the migration. And also there are a couple of conceptual difference from Gradle, like how build config or resource values are read and passed, stuff like that. So this needs to be evaluated. And since there are missing features, it makes sense to have a dedicated group of build or developer experience engineers who can contribute this missing support for a build. And at the same time, automated migration mitigates the risk of maintaining two build systems. So when you automate the build, and since Bazel build scripts are easy to generate because it is very simple Starlark based configuration, it makes sense to generate them and keep Gradle as a source of truth. And this mitigates your risk of, let's say, two build system going out of sync, and that, etc. And yeah, so at the same time, when you have large number of build or Bazel file, you can automate them and reduce the burden of maintaining the build script manually. That's all I have. Thank you. I hope we have time for questions.
Yeah, thank you. It was really interesting and brilliant talk, and I think it was a lot of new things for most of us because not every spectator are common with Basil. We are the Gradle people. So let's begin. Do you have or know an example of build time using Gradle via Bazel or Bazel using many models?
Bazel using many models. Yeah, so one of the things known advantages of Gradle versus Bazel is the configuration, caching, and the instant execution, right? So but Bazel by default out of the box supports configuration caching. So if you have not enabled Gradle's configuration caching yet, and if you're trying to do a build, you definitely save a couple of seconds or minutes there by default with Bazel's configuration caching. Apart from that, you have Kotlin's ABA-based compilation avoidance, which means that if I make a ABA compatible change on a module, Bazel is going to be really fast compared to what we have on Gradle today, and unless you use Kotlin 1.7. So that way, the improvements can range anywhere from 30 to 40, but depends entirely on project configuration. If your project is having a lot of large modules, anyway, Bazel is gonna spend a lot of time compiling the big modules. But if your build graph is very small, like if you use Bazel correctly by splitting the targets into multiple targets, then it is going to be quite good.
Does Bazel support special cases like Hill's byte code transformation that is executes using Gradle plugin?
Yeah, so Bazel at the moment does not support Gradle's transform. There are a couple of ways to get it working with a simple macro, but at the moment when you use Dagger Hilt with Bazel, instead of using the extending from the activity, you simply the generated activity. That is exactly what Hill's bytecode transform does. It transparently rewrites the code such that you extend the generated activity that you need to do manually. We did not get a need to invest time into migrating the Gradle transform into Bazel, But I've seen a couple of examples in OKBuck repo from Uber. They have a transform CLI, and I think it is quite possible to write a macro that helps to set up ways set up such that you are able to use Hills bytecode transform as well.
Thank you. Next question. What is the benefit of having Bazel per package instead of having models per package?
Bazel per package instead of modules per package. I'm assuming that when you have like lot of Bazel, like I have a very big Gradle module, which like let's say had 30 packages. I'm assuming the question about what happens when you have like 30 different um, packages, right? So one of the thing, this 30 newly introduced Bazel packages needs to be properly written. It should not have any unused dependencies, and the dependency graph should be valid. If it is not valid, what ends up happening is that uh, you're not gaining, going to compile them serially. And at the same time, one of the risks of having too many packages that your cache size might grow. So that is also a concern when you use remote caching. And in our own experience, Bazel is quite cache heavy. That means compared to what Gradle does, Bazel caches everything. So your remote cache probably for a single build might be order of GBs when you have a considerably sized project. So that is another concern.
Thank you. Uh, One more question. A third part SDK came with Gradle plugin. It's unusable from Bazel when SDK developer doesn't explicitly support Bazel.
Uh,
So it's,
okay.
I think it's some difficult case from some personal practice. What do you think
Okay.
about
So
such combination?
yeah, we have faced something like that. So for example, let's take Realm. So Realm relies on bytecode transform to did most of this work. And as I already said, it does not support Bazel does not have a easy way to perform transform yet. So that is something that needs to be manually written. So let's say you have a wrongly published Maven library. So Maven library is published without any uh, implementation or API configuration correctly. Bazel is quite strict in catching those cases. So what we have done is that we have manually fixed the libraries and published them internally, or we just run the patched version of them locally for our builds. But this is definitely a case where something works in Gradle and it does not work in Bazel. And it is not to fault both of the build system. It's just that the way that they are implemented in catching, implemented in their lint checks. Yeah.
Thank you. One more question. How do you handle build variants and flavors? I think that's really important moment when we are
Yeah.
making a really multivariant application for debug or just release modes.
Yeah, so I mentioned one in my Android binary, right? It is just a function call. I cannot write a if-else statement, or I cannot do anything. But in Gradle, we are used to have writing imperative code in the build protocol. So one way that we are planning to support build variants, even in Gradle, is to simply have different targets for two different configuration. For example, a single module might have Android, let's say a production variant and a staging variant. We simply write two different Android library rules, and we are looking to possibly automate this with Gradle, so that Gradle can simply read the Android flavor info from Gradle and automatically generate the two different configurations as you would need.
Is it possible to do everything you can do in Gradle using Bazel? I think that you have already answered this question, but could you summarize one more time?
So uh, uh, in short, the answer is no, right? So both build systems, even though there are a lot of similarities, there is quite a bit of divergence into what they want to do ultimately. For example, Bazel is focused on parallelization and caching heavily, and at the same time, Gradle's priority is like incremental builds. So Gradle excels in incremental builds, like you modify a file and Gradle is able to track the file changes and do that. So I would not say that you can do everything, but even if something is not supported, I have found that Bazel rules and macro APIs gives me confidence that we can implement the missing features. I'll give an example. For example, Gradle has build config fields, Bazel does not have a concept like that, but we were able to write a simple macro that sort of bridges this gap, right? So we can write a macro that takes a set of strings generated at runtime, put it on the class path, something like that.
Thank you. Also, there are a question about your stack. Have you seen Catalang, a cut version of Kotlin to replace Starlark?
Yeah, I have actually seen Kitolang. It was quite interesting for me. It is something that uh, I've been interesting to try myself, but I did not have knowledge on the compiler plugin part. So Kitolang, as I understand, is a compiler plugin that helps you to write Kotlin, but similar to Starlark. So you can't have file APIs or basically do a lot of things that Starlark does, but still use Kotlin. One of the things that I mentioned, Starlark is dynamically typed, but I tend to prefer strongly typed languages. So it would be amazing that at some point in time, I'm able to use Kotlin, but at the same time, it is being performant as well.
Okay, thank you. Very important question for everyone who are interested in Bazel at this moment. Are there any resources or books you can recommend to deep dive into Bazel best practices or guides?
Yeah, I can probably share a couple of links. So in the renewed interest in setting up uh, co- code labs for Bazel starters. Like how do you start with Bazel and stuff like that. I also know that a team from Spotify have worked with Ray Wenderlich to create a multi-part free course where you start from Bazel basics and end up with remote execution. Can probably share the link to that after this chat.
Okay, and would you recommend to migrate Medium project to Bazel? Would be expected benefits?
Yeah. So as I said, right, so there are ways to do effective Bazel. So that means that I would not say, okay, you migrate your Bazel to your medium project to Bazel today and you automatically expect benefits. So it really depends upon the project configuration and the things that you're wanting to do. Let's say you want to use remote execution. You're finding that build is a bottleneck and you want to use remote execution. Bazel makes a good argument to do that. And one thing that I forgot to mention in my talk is that Bazel by default parallelizes the task across your projects compared to what Gradle does. So in Gradle, if you use configuration cache, your same project tasks are going to be parallelized. But if you don't have configuration cache, same modules tasks will still execute serially. But that is not the case with Bazel. As and when immediately you break down your build, Bazel is able to look at the dependency graph and immediately start executing parallelly. So that means that there is a potential chance that if you have a very powerful machine like M1, it is possible that because of the increased parallelism, you'll start seeing benefits. And I should also note that there are costs to set up the initial rule structure and what things to do and things not to do. And I believe this needs to be evaluated on a team to team basis.
Okay, thank you very much. And the last question, we have two questions from same spectator, so we will combine them. Will Bazel make the builds reproducible automatically? And uh, if it support to write custom collection classes to avoid quadratic complexity?
Uh, yeah, so two things, right? Bazel makes my build reproduce automatically. Unfortunately, no. It was a conception I also had. It seems that Bazel is quite sensitive to changes that you make. So let's say that I'm producing a zip file, right? So zip files are notorious for having timestamp embedded in them. So if you have a right if you write a custom rule or custom macro that is producing a zip file or any other file and it is undeterministic, meaning it contains absolute path or the generated code is on a different order every time, Bazel is not going to help here. However, I have found that it is quite easy to debug those cases. So Bazel provides tool called execution log file, where you can have hash sum of every file that is used in the build. So you can run two builds, compare the whether the hash files are same between the two builds. If it is not the same, then that means that your build is non-deterministic. So when your build is non-deterministic, Bazel is simply going to fall back into regular compilation. I would say that it makes sense to migrate your build, run the execution log file, which is similar to Gradle build scan, open it into VS Code, compare the diff, make sure you don't see any changes at all. If you don't see any changes, then it is very easy to say that Bazel's cache performance will be quite good, because in our own experience, once we fixed all those issues with the zip files or any other determinism, we were able to hit 99% cache hit rate. Yeah.
Yes, and the last question before we'll finish, because then the next speaker will come here with another host, and we need some break. Is this open source or not?
Yeah, so Bazel itself is open source. You can simply check out the source and start compiling. The rules Kotlin is open source. The Gradle migration tooling for migrating from Gradle to Bazel, it is also open source. Most of the components that I discussed today are open source.
Thank you very much. That was really awesome talk. And we would like you to share your slides and maybe some your samples of your code, your GitHub on the Slack, and here in general chat for every spectator. So we are really excited. Thank you very much. That was awesome. And thank you that you stayed with us um, and you wasn't scared with these old technical difficulties, and you made a perfect presentation. Thank you very much. That was really
Thank you.
awesome.
Thank you so much for having me here. And thank you all folks to adjust for adjusting with the technical issue. Thanks a lot.